Today we're looking at combinations of transformations. You'll be able to apply more than one combination to a matrix at a time. Combination, that should definitely say transformation. Alright. So combined transformations are made up of two or more transformations. So when transformation T1, let's call it T1, is applied to the point x, y, the result is p dashed x dash y dash. And then if we apply transformation T2 to p dash, then the result is p dash dashed. So in matrix form we can summarize that as x dash y dashed is equal to T1, and that's T subscript 1, x, y. Right, that's what we're saying in this first line here. This first line says that T1 is applied to pxy, so when T1 is applied to xy, we get out p dashed, or x dash y dash. So when we want to work out what is x dash dashed after two transformations, and let me just clear that up a little bit so it's easy to see, dash dash, then that's going to be equal to the second transformation. It says here, so when we apply T2 to p dash, we get out p dash dash. So if it's dash dash we're getting out, we have to times T2 by this p dash point. Right, the question now is, can we use these two bits of information, this one here and this one here, to work out a more general rule for transformations of matrices? And what we might be able to see is that x dash y dash we know is equal to T1 x1, and we've got an x dash y dashed here. Alright, so what we can do is substitute this guy into here, and what the result is, it'd be x dash dash y dash dashed is going to be equal to T2 times by this green guy, which is T1 x y. Right, and this can then give us a more general rule that we're going to be able to use, and we can rewrite this in non-matrix form if we'd like, although perhaps the easiest way of thinking about it then is that the overall transformation matrix, if we want to apply two transformations at a time, we have to say T2 and then T1 to get the overall transformation matrix. So that means that our overall transformation matrix, let's just call it T, is going to be equal to T2 T1, and that comes from here, T2 to T1. So to get to our eventual point we need to multiply it by T2 times T1, and we're just going to call T2 times T1 T by xy, so we can rewrite that as well. X dash dashed y dash dashed is going to be equal to T multiplied by x, y, and in this case T is going to be T2 T1. So to work out any questions we need to do T2 times T1, so it's the second transformation has to be multiplied by the first one in that order. So taking a look now at an example, we want to determine the single transformation matrix T that describes a reflection in the x-axis followed by a dilation factor 3 from the x-axis. Alright, so in trying to work this problem out, we've got a few little bits of language that we need to try and wrap our heads around. So first up we need to think about what the two transformation matrices are to be used. So T1 is a reflection in x, and let's just try and think our way through this. Alright, so if we're reflecting in the x-axis, we might think about having an initial point that is here, and if it's reflected about this axis here, then the final point will be here. So therefore we would have, that would be p, that would be p dashed, so we'd have the same x-coordinate but a different y-coordinate. So the y-coordinate would be the negative value of what it originally was. So p dashed, the x of p dash will be the same as the x of p, so we could say, probably not great notation, this is what I can do. I can say p dashed x dashed comma y dashed is equal to x comma negative y. Alright, so the x in the x dashed is the same, but the y in the y dash is equal to the negative y value. So if it's a negative y value, the matrix that we need to come up with has to have the same x value but a negative y value. And so when we're thinking about that, we're going to have T1 is going to be equal to 1, 0, 0, negative 1, because if we multiplied this out to a point of x and y, which we're not going to do, we would end up with x times by 1, or 1 times by x, 0 times by y, so it would be positive x, and then 0 times by x, and negative y. Cool, so we thought our way through that one, but we don't need that there, so T1 is there. The second matrix that we need, T2, is a dilation 3 from the y-axis. From y-axis. Alright, if we're going from the y-axis, we're thinking, alright, if there's an initial point here, let's call that P. From the y-axis means we're starting, I think we start from at the y-axis and we must be moving from it. So moving from it, we must be going out this way somewhere, so P dash must end up here. That means that we're going parallel to the x-axis, and a parallel to the x-axis means that the dilation matrix needs to impact upon the x-coordinate. Alright, and so if it's impacting upon the x-coordinate, we would need a matrix where this one here, so these twos would be zeros, but this element up here would be the one that impacts upon the x. That one multiplies by the y. So T2 is going to be equal to K1, 0, 0, 1, where in this case K1 is equal to the dilation factor, which is equal to 3. So therefore T2 is going to be equal to 3, 0, 0, 1 in that order. Great. Alright, then we need to think, alright, well, how do we get from these two individual matrices to one final overall matrix? So the next thing we need to think is, and these are two thoughts, how do I get T being the overall transformation matrix? From there we can get our formula. So we know that our formula is going to be T is equal to T2 times T1. And we've shown why that is up here. We used some substitution and worked out that T2, T1 is going to be equal to T. Once we've done that, we then apply, or we substitute and apply a multiplication. So substitute and apply a multiplication, so T, oops, it's one colour. T is going to be equal to T2, T1, oops, it's the same line written twice, I probably didn't need to do that. T2 is a 3-1 dilation in the x, parallel to the x. 3, 0, 0, 1, and then T1 is a reflection about the y, reflection in the y, so 1, 0, 0, negative 1. So we can then go ahead and apply that multiplication. We say 3 times by 1, which is 3, plus 0 times by 0 is 0. We say 3 times by 0 is 0, plus 0 times by negative 1 is 0, 0 times by 1, 0, 1 times by 0, 0, lots of zeros going on here, and then finally where are we up to? 0 times by 0, which is 0, plus 1 times by negative 1, which is negative plus negative 1, which ends up giving us 3, 0, 0, negative 1. So that would be our overall transformation matrix T. Alright, we could go on and use that transformation matrix to apply to a point. We haven't been asked to do that in the question, so that's the end of the question there, and we're all done. Definition. What I'd like you to take down is this guy here, a combined transformation, and that can be the definition there, and that's more, 2 or more, that word's meant to say more there. Alright, good stuff, see you in class.